Okay, this is going to be a little different than Algebra 1 also. This time we're going to graph quadratic inequalities, okay? Here are the steps. There's two different ways to do it. We're going to do it with graphing and we're going to do it algebraically. So let's start with the graphing. The first step is to graph the parabola or the quadratic. When you graph the parabola, this is the hardest part. Decide whether you have a dashed or a solid line. Remember, dash is less than or greater than, solid is less than or equal to, greater than or equal to. That's how we know if it's dashed or solid. Okay? Second step, test a point inside the parabola. If the test point makes the original inequality true, then you're going to shade inside the parabola. If the test point makes the inequality, the original inequality, false, then you're going to shade outside the parabola. Okay? Questions, concerns, issues? Oh, that's right, I'm on a video, so I can't take that. So let's do two of these, okay? Really, we're just building on what we did before. So, if y is less than or equal to x squared minus 4x minus 1, we need to graph that. So, you can do a couple things. You can just go straight to your graphing calculator, do your table of values, which is what I did. And to make this shorter, I'm not going to go through all of that. I graph my points. So my points are 2, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I should have written them down, but that's okay. And then, oh, that makes you sick, huh? All right. Now, before I connect it, is this a dashed or solid line? Well, we have an or equals to, so this is a solid line. I pick any test point I want inside the parabola. The one I happened to pick when I was doing this example was 1, 2. So I picked this as my test point. And I'm going to plug it into that original inequality and see if it makes it true. So instead of y, I put my 2. Instead of x, I'm putting 1 in both x places. And then I just figured out what was on the left side. So is 2 less than or equal to negative 4? 2 is not less than or equal to negative 4. This is a false statement. Therefore, I need to shade outside here. Okay, so now I shade outside the parabola. Okay? All right, let's do another one. And then I'll show you how to solve it algebraically. Y is less than negative 3x squared plus 4x plus 8. Okay, I'm going to do the same thing where I'm going to graph it. Oh, and I made this hard on myself. So it's 1/3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1/3 and then 1, oh, and then 9. 4, 5, 6, 7, 8, 9. So it's going to be up here like this. And then it's going to be 1, 0 here. And then it's going to be So make sure when you're graphing it, you might want to put a little table. This time it's going to be a dashed line. And this time I'm going to make it really easy on myself because inside this is 0, 0. So I'm going to use test point 0, 0. So is 0 less than negative 3 times 0 squared plus 4 times 0 plus 8? Is that true? Well, yes, 0 is less than 8. So that's true. So that means we need to shade inside the parabola. Okay? That's how we would solve an inequality graphically. Now, if we're going to solve it algebraically, it gets a little bit more complicated. So pay close attention here. I've made some steps to solve inequality algebraically. Just making sure I spelled that right. Okay. The first step, make one side of the inequality 0. Second step, factor your favorite. Third is to use the zero product property. Now, it could be difficult and make you do quadratic formula or completing the square to do this, but we're going to stick with just where the answers are a whole or fraction numbers, so you don't have to worry about irrationals. Zero product property to find the boundaries. That's what this is going to give us. We're going to put the boundaries on a number line. We're going to test each segment. And then we're going to write an inequality. It's a lot of steps, but they're pretty simple steps once we do a few, you'll see. Okay? All right, so let's start with this one. So x squared plus 3x is less than or equal to negative 2. First things first, it needs to be equal to 0. So I'm going to add 2 to both sides. Now I could graph this and just come up with the graph to see where it was. But I'm going to figure this out algebraically this time. Now, again, if you don't know how to factor, you're out of luck again. I keep telling you, you got to know how to factor x plus 2 and x plus 1. And then we're going to use our zero product property to find our boundaries. So x plus 2, if that equals 0 and x plus 1 equals 0, our two boundaries are going to be x at negative 2 and x at negative 1. Here's what I mean by boundaries. I'm now going to draw a number line. And on that number line, I'm going to put negative 2 and negative 1. Now I have 3 segments to test. Now, on those boundaries, to decide if it's a closed or open circle, I look back at my inequality. Since it's less than or equal to, we know we have a solid on both of these boundaries. The question is, does our x fall between them or away from them? So what I do is I test each part. So I come over here. Well, over here, negative 3 is over here. Okay? So I'm going to go back to my original, and I'm going to test negative 3. So negative 3 squared, in parentheses, plus 3 times negative 3 plus 2, is that less than or equal to 0? And that's false, because we're going to get 9 minus 9 plus 2. Well, 2 is not less than or equal to 0. So this is false here. I'm going to test between the two. So I can test negative 1.5, and I just throw it into my calculator. And that's going to be true. And if you test over here, this is going to be false. I'm just trying to shorten the video up here a little bit. Now that I have my true and false on here, I can write my x. And I can see that x is true between these. So x is less than -1, but greater than or equal to -2. And that's my answer. If we were to graph that, that's where we would be shading. Okay? All right, let's look at another one. I have -x² minus 6x plus 7 is less than or equal to 0. My first thing is I don't want a negative in the front. I do not like a negative to factor, so I divide everything by -1. So that gives me x² plus 6x minus 7 is less than or equal to 0. I factor it quickly. I do my zero product property. So x plus 7 equals 0, x minus 1 equals 0, so that means my boundaries are -7 and +1. So I draw my number line, I put my -7 and my 1 on there. I decide, do I have opened or closed circles? I have closed circles, and now I have to test each section. So over here, I might test -8 and see if that's true. In this case, that makes this true. In between these two, I would test 0. 0 does not make our inequality true. It makes it false. And this one's true over here. And we'll spend some more time on these showing you how to do the test points. Now, how would I write this? Well, x is over here this time. So that's less than or equal to -7, or x is greater than or equal to 1. So that's how we do that one. I'm going to do the rest in class just to save some video time. And then we'll make sure that we go through these a little